Hi all, Mrs. Saller here again, going through one of these calculus problems that you have for homework tonight. That's due Monday. So I want to take you through the 2009 number 2, which is another one that deals with a rock concert, and it's a calculator OK question. And it says the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by this function. So r of t equals 13t squared minus 675t cubed. For the interval 0 to 2 hours, r of t is measured in people per hour. No one is in the auditorium at t equals 0 when the doors open, the doors close, and the concert begins at time equals 2. So part A asks how many people are in the auditorium when the concert begins. So we were just told that in part, the whole given information, that the concert begins at time equals 2. So we're given a rate, so if we want to get the total number of people in the auditorium, we're going to take the integral from 0 to 2 of that rate. So of r of t dt. Which means in our calculator, we're going to take the integral from 0 to 2 of the 1380 t squared minus the 675 t cubed with respect to t. And of course, this is something we could take the antiderivative for, but why would we even bother when we have the calculator? So let's go ahead and plug this in. We're on math, option 9. Oops, let me move this over so you guys can see it. So math option 9, and we're going from 0 to 2. Of our function, which in this case is the 1380 t squared minus the 675 t cubed, and with respect to x, we're going to do dx, and press enter, and we get 980. Okay, so really nice number. We get 9, actually I can lose the approximation symbols then. So it's going to be 980 people are in the auditorium at that particular time. So that's part A. Pretty straightforward. You're just going to plug it into your calculator and get the answer. Now part B says find the time when the rate at which people enter the auditorium is a maximum. So the rate is a maximum. So we're trying to maximize r of t. So to find the maximum, you have to take the derivative. So let's take the derivative in part B of r. So r prime of t is going to equal, now you have to take this derivative by hand. So let's go ahead and do that. So we have, oops, let me get my calculator up. So we have 2780 or 1380 times 2 to get that constant, so 2760. Time minus, and again I'm just taking the derivative, so the derivative of the negative 675 t cubed is minus 2025 t squared. And we're going to set that equals 0, or see where it's undefined. Helps us find maxes and mins, but obviously it's not undefined. You only get undefinedness when you're dividing by something with t in the denominator. So in this case, we have to set this equal to 0 and solve. I'm going to go ahead and factor out the t. So we get 2760 minus 2025t equals 0. So we get two possibilities. Time equals 0, which is an endpoint, so it's a possibility anyways. But then we also get the 2760. Wow, I wrote down way too many zeros in that one. 2760 minus 2025t is equal to 0. Solve this thing. And you get another possibility, and this you have to plug into your calculator to figure out what it is, but it's about 1.363. So now this is a possible max or a min, so we have to test it. So make an r prime chart to test it, and we're going from 0 to 2, so don't go outside those boundaries. We'll put the 1.363 on there, and test the number to the left and the right. So I'm going to choose 1 and 1.5 to test it out. Make sure you're plugging it back into the derivative. So I plug in 1, actually here's the derivative rather, plug in 1, you get a positive times a positive, which is positive. When you plug in 1.5, you get a positive times this will turn out to be a negative. So sure enough, we're going from a positive to a negative, so that definitely is a max that's happening there. Alright, so we can actually say that's a max. So then for the next part of it, it says justify your answer. So we would just say that r has a maximum at time is about 1.363. Since r prime of t changes from positive to negative at time is about 1.363 and is the only critical point. And the only critical point makes sure that this is an actual absolute maximum and not just any maximum. So the rate at which people are entering the auditorium is a maximum at time is about 1.363, since r prime t changes from positive to negative at time is about 1.363 and is the only critical point. Now in part C, It says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W models the total wait time. So W is going to give us the total wait time for all the people who enter the auditorium before time t. The derivative of W is given by W prime of t equals 2 minus t r of t, and we want to find W of 2 minus W of 1, which is going to give us the total wait time for those who enter the auditorium at time equals 1. Alright, so to find that, we're going to have to take the integral of W prime of t, which is that 2 minus t r of t, and we're going to go from 1 to 2. Because this, let's just show you why this works. This would be W of t, and we're going to evaluate it from 2 to 1. So that would give us W of 2 minus W of 1, which is what we're looking for. So what we're going to do is take the integral from 1 to 2 of that W prime of t function, which is the 2 minus t, times R of t, which R of t is that function they gave us at the beginning. And we're just going to plug that straight into our calculator. So let's go ahead and do that and see how many hours in total wait time there is for everybody together. So let's go ahead and enter this in. So math option 9, we're going from 1 to 2. We have parentheses 2 minus t, so 2 minus x, close that parenthesis, times R of t, which is the 1380 t squared, so x squared, minus 675 x cubed, and then gotta close that parenthesis, and then dx, and then press enter, and we get 387.5. And that's hours, and that's the total amount of wait time that everybody put together. So like if I was waiting 5 hours, the person next to me was waiting 6 hours, you put all those hours together for all the people in the auditorium, that's what you're going to end up with. Now part D is a little bit tricky. Let's take a look at part D. It says, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open, and use the model for total wait time from part C. Okay, so really simply, we need to find the total amount of wait time. So to get the total amount of wait time, we're going to take the integral from 0 to 2 of that W prime of t, which is the 2 minus t times the R of t function, so 1380 t squared minus 675 t cubed, with respect to t. Now this will give us the total wait time, so let's find that first. Okay, so I'm just going to go back and second entry this, and just scroll back and change that 1 to a 0. It's probably the quickest way, so you're not re-entering this so silly integral by hand. And then press enter. Now it's 760 total hours of wait time, so that would be the total wait time, 760 hours. So to figure out the average wait time per person, we're going to take the 760 hours and divide by the number of people. So the number of people we found in part A was 980 people. And just plug that in your calculator. So divide by 980. And you get about 0.776 hours. Per person is the average wait time, which kind of makes sense. I mean, you think about these people waiting. Some people like get there at 0 hours and be waiting 2 hours, and some people like get there 1 hour waiting 1 hour, and there's people that show up, just before it starts. So when you average all those people's hours together, actually it's going to be 0.776 hours per person. So everybody on average is waiting about 45 minutes is really what that's going to turn out to be. Alright, so now that should give you enough to kind of work with. So you guys have those other 4 problems in that packet to finish for Monday. I will be checking that in. If you're part of the AP Psych or I forget what the other one is, but the other AP exam on Monday, just make sure you show it to me first thing Tuesday so you get the credit for this. And this will be my last real check-in grade for you guys. Otherwise, at this point, I'm just going to say, here's stuff, do it if you want to do it, because at this point, we're getting so close to the AP exam, I'm not going to have as much time to check in as I usually do. If you have any questions, feel free to drop by either before school or after school in the next couple of days, and good luck with the rest of those problems, and I will see you guys tomorrow. Thanks.